Now in this lecture, we are going to implement our algorithm that we have learned in our previous lecture in Java. So here inside CircularSinglyLinkedLis class, we are going to create a new method which is responsible for inserting a new value to the CircularSinglyLinkedList. Now here we are going to combine all three cases that we discussed in our previous lecture in one method. So I'm going to declare our method inside this CircularSinglyLinkedList class like this. So the method name will be public void insert CSLL. Now as a parameter, this method will take two parameters. So the first parameter will be integer node value. Here we are putting integer because when we are declaring node over here inside the node class, we have set that our value is integer. So if you set your value as a string, so you have to set parameter of this method as a string. Now the second parameter will be location. So and this one's going to be integer. So this is the index of the location in which we want to insert our node. Now inside this method, the first thing that we are going to do, I'm going to create a new node and set this node value to this new node over here. So I'm going to create a node and with the smaller letters node based on the node class that we created over here. So this is the node class. So here we are going to create this node based on this node class. And I'm going to assign this node value to this newly created node. So node value will be node value. Then we are going to check that if our single linked list exists or not. So if the head of single linked list is null, it means that it does not exist. So we are going to call this create CSSL method to create CircularSinglyLinkedLis based on this node value over here. So as you remember, when we are creating this method, we have said that when we are creating CircularSinglyLinkedLis, we have to set a node value. So when we are creating it, there's going to be only one node in our CircularSinglyLinkedLis. So here I'm going to write if condition like this: if head equals null. In this case, it means that we have not created CircularSinglyLinkedLis. So I'm going to call create CircularSinglyLinkedLis with the value of node value that comes from this parameter. So after doing so, we don't need to continue our method. So I'm going to put over here return. So we have to come out of this code over here. Now in the else condition, we are going to implement our three cases. Now the first case was we are inserting an element at the beginning of single linked list, and the second case is we are inserting an element at the end of CircularSinglyLinkedLis, and the third case is we are inserting an element at specified location. So we have said that if location parameter is equal to 0, in this case we are inserting a node at the beginning of CircularSinglyLinkedLis. So I'm going to implement the logic that we discussed in our previous lecture. So we said that when we are inserting a node at the beginning of CircularSinglyLinkedLis, the first thing that we are going to do, we are going to update the next reference of this newly created node to point to the first node. So I'm going to set node.next to point to first node. Now we know that in head we have a first node, so that's why I'm going to set it to head. Now the next thing that we are going to do, head has to point to this newly created node, because in this case this newly created node is going to be our first node. So head has to point to this node. Then at the end, we know that in case of CircularSinglyLinkedLis, last node has to point to first node. So this means that we are going to update the next reference of last node. So if I access tail.next, it means that we are accessing last node's next reference. If I put it head, now in head we have a new node's value. So it's going to update the last node's reference to point to first node. Now with this, we have completed insertion of an element at the beginning of CircularSinglyLinkedLis. Now in the else condition, I'm going to insert an element at the end of CircularSinglyLinkedLis. So if location parameter is greater or equal to size of the CircularSinglyLinkedLis, so this size comes from over here. So as you remember, when we are creating CircularSinglyLinkedLis, we have set property of size. So whenever we are inserting or deleting an element, we are going to decrease or increase this size over here. So if the location parameter is greater or equal to size, this means that we are inserting an element at the end of CircularSinglyLinkedLis. Now when we are inserting an element at the end of CircularSinglyLinkedLis, the first thing that we are going to do, we are going to update last node's next reference to point this node over here. So this node is our new node, so I'm going to update tail.next. So tail.next is the last node's next reference. It has to point this node over here because this node is going to be the last node in our CircularSinglyLinkedLis. Now the next step is tail has to point this node, so tail has to point this node over here. Then this node's next reference has to point to first node. So in this case, if I access the tail.next, because we have set over here that tail has to point this node, so tail.next will be last node's next reference, so I'm going to set it to head. So if I set it to head, it's going to reference to first node. Now with these 3 lines of code, we have finished implementing of inserting a node at the end of CircularSinglyLinkedLis. Now in the else condition, we are going to implement the logic which is for inserting at a specified location. Now as we said, when we are inserting a node at a specified location, we have to start from the first node and loop until the location that is provided in the parameter. And when we reach that location, we are going to insert a new node between current and next node. So what I'm going to do, the first thing that I'm going to do, I'm going to create temp node over here and set head value to it, because we are going to start from the first node. And then I'm going to create an integer over here, index, it will start from 0. This will help us for looping. So while index is less than location -1, then in this case we are going to continue to the next node. So to continue to the next node, I'm going to set temp node to temp node.next, and in each iteration we are going to increase the index variable by 1. Now with this, we are traversing through the single linked list and we are reaching to the point where we want to insert a new node. Then after reaching this point, we are going to set newly created node's next reference to point to the next node. So here, node next will be set to temp node's next reference. Now we know that temp node is our current node, so temp node's next reference will be the next node. So we want to insert new node between current node and next node. So if I set new node's next reference, current node's next reference, it means that we are referencing new nodes to the next node, and then current node has to reference to new node. So in this case, temp node.next has to point to new node. Now with these 2 lines of code, we are inserting a new node between current node and next node. Then at the end, we have to increase size property by 1, because in each step, when we are calling this insertion method, we are inserting only 1 node. So that's why every time when we are inserting a node, we are going to increase this size parameter by 1. Now with this, we have finished our insertion methods. So basically here we have combined all 3 cases in one method and implemented them in Java. Now let's see how this is working in practice. Now as you remember, in our main Java class, we have created a CircularSinglyLinkedLis and we have a value of 5 over here. Now after this creation, I'm going to call CSLL insert CSLL. So if I insert, for example, the new value of 4 at the index of 0, this means that if you print the head value, it has to print 4, not 5, because we are inserting an element at the beginning of CircularSinglyLinkedLis. Now if I run our code, now you see that the head value is 4. So let's insert few elements in other locations. So in this case, I'm going to put 1 over here. Then I'm going to put, for example, 8, which is greater than the size of the CircularSinglyLinkedLis, and run our code to see that everything is working correct or not. Now you see that everything works correct. So because our method is not giving any error over here. So when we are creating traversal method, there you will see visually all nodes that are located in their positions that we have inserted from here. Now let's see what's the time and space complexity for this method. Now here, as always, we are going to start from the first line of code. So in the first line of code, we are creating a node and assigning node value to it. Now these 2 lines of code will take a one-time complexity because these are not time-consuming operation. Then inside if condition, we are checking that if head is equal to null, then we are calling this create CSSL method. Now in our one of previous lecture, we have learned that create CircularSinglyLinkedLis takes a one-time complexity. So this means that this if condition over here will take a one-time complexity. Now in the next if condition, we are checking that if location is equal to 0 or not. So this if condition will take a one-time complexity. Then inside this if condition, we are updating the next reference of new node, and we are updating the head to point to new node and last node's next reference to point to this new node over here. And these 3 assignments over here will take a one-time complexity because these are only simple assignments over here. Now similarly, in the next if condition, we are checking that if location is greater than size, we are doing some updates to the other assignments. So this one is similar to the previous if condition. So this means that this one also will take a one-time complexity. Now when it comes to else condition, here we are creating a new node and setting to head value to it, and then we are creating new variable and setting 0 to it. Now these two assignments will take a one-time complex. Now then we are continuing to this loop over here. So inside this loop, we are looping through all elements of CircularSinglyLinkedLis. So in the worst case, if the element is almost located at the end of CircularSinglyLinkedLis, so for insertion at that specified location, it will take O(n) time complexity. Because if the number of elements in the CircularSinglyLinkedLis is n, then we have to traverse all elements of the CircularSinglyLinkedLis until we reach the specified location. So in this case, the time complexity for this loop over here will take O(n). Now inside this loop, each time we are updating temp node to the temp next, and we are increasing index value, and these two lines of code will take O(1) time complexity. Now at the end, we are updating newly created node's next reference to point to the next node, and current node's next reference to point to this node. And these two lines of code also will take O(1) time complexity, because here we are just doing update to the next references of these nodes over here. Now at the end, the size is increased by 1, and this means that it will take O(1) time complexity. Now if we combine all these complexities over here, we will get O(n) time complexity, because all non-dominant terms which are O(1)s will be eliminated. Now then we are left with the O(n) time complexity, so this means that insertion method in CircularSinglyLinkedLis will take O(n) time complexity. Now the space complexity is O(1) because here, whenever we are calling insert CircularSinglyLinkedLis method, we are inserting only one node to the CircularSinglyLinkedLis. So this means that it will take O(1) space complexity. Now with this, we have come to the end of this lecture. So in this lecture, we have implemented insertion in CircularSinglyLinkedLis based on the algorithm that we discussed in our previous lecture. So hopefully everything is clear about this method. Now see you in the next lecture.